So as we know in last class, we studied the fifth property of acids, metals. So when the metals reacting with the, what everybody? So reaction with metals reacting with the dilute acids. So as we know that we are having a metal activity series. So if any kind of metal, generally we are saying, so metals reacting with the dilute acids, we are getting the products. What is the products, guys? Everybody? Yes, please. We are going to get metal salt plus, what is the gas we are going to get, everybody? We are going to get the hydrogen gas. So this is the generalized equation whenever the metals reacting with the dilute acids. And we studied that some metals will react with easily, more faster. Some metals, it will take time to react. Some metals, reaction is minimum at the beginning. After certain time, it will be goes, reaction rate increases. So what is a metal which at the reaction rate is minimum beginning and after some time it will increases? Anybody? Yes, please. A metal reaction rate is decreases at the beginning, it is slow down, and after a certain time the rate of reaction increases. Anybody?
Aluminium.
Aluminium. So because of a protective layer of, what is that?
Aluminum oxide.
So that is the reason before reacting we have to rub with what paper? Every metal. Sandpaper like aluminium, iron, zinc, and all. So then we know that highest reactive metals. Who is the metals will react very fastly and as well as violently? Everybody. Very fast and violent. Everyone. They are having some name. Sodium and potassium. There is a name for that. What is that, everyone? Who is
alkali metals.
Alkali metals. So alkali metals are like example sodium and potassium. So they are very fast and as well as violent. So this all the metals will react with only we will take two acids. What is the famous acids we will consider, everybody? One is hydrochloric acid and another one is what?
Sulfuric acid.
Sulfuric acid. But there is acid, one more mineral acid, which we all people know. That is what we used to call as. What is that? Nitric acid, HNO3. So HNO3, most of the metals won't be produce hydrogen gas. They will react, but due to the strong oxidizing agent, as it is strong oxidizing agent, instead of hydrogen, we'll get what, guys? Everybody. We'll get the responder. Instead of hydrogen, we'll get what? Everybody. We'll get water. Understand? So that is the reason we won't react with the nitric acid. But basically, there is a two metals who will even react with nitric acid and will produce hydrogen gas. What is the two metals, everyone? The only two metals which will react with the nitric acid and they'll produce the hydrogen gas. What is that? Please respond. One is
manganese.
Another one is manganese. We have written the two equations. I hope you all learned the two equations. Everybody clear? Anybody having any doubt? You can ask me. And there is a metals who won't even react with anything. That is what? Even with the concentrated acid or dilute acid, that is what we used to call as, what is that? Gold and platinum. Yes or no? So platinum. So these metals will never react with dilute acids as well as concentrated acid. But if you mix two acids in a proper ratio, that is what we used to call as 3:1 ratio. What is the 3:1 ratio? Concentrated HCl versus 1 percentage, how much? 3/4. That is what? Totally 4. So 3/4 of HCl and 1/4 1/4 of what, everybody? 1/4 of HNO3. So that is what? 3:1 ratio. So 3:1 ratio of volume if you prepare, that is what the mixture of the two we used to call as something. What is that called as, all of you? We used to call as Aqua
Aquaria.
or that water we used to call as what? Royal water.
Royal.
It is the one which will use to dissolve gold and as well as platinum. So, but the ratio is always remember 3 is for HCl and 1 is for HNO3. Even that reactions also I told you. Am I right, everybody? So keep it in mind, in these reactions, there is a nascent chlorine will release. What is a nascent chlorine? Cl2 or Cl? Everybody. Cl.
Cl.
Nascent means it is Cl. Nascent means oxygen also. Nascent oxygen means what will happen? Nascent oxygen. So which is more reactive? Oxygen atom or nascent oxygen? Which is more reactive?
Nascent oxygen.
Fresh. It is a very fresh and pure nascent oxygen, which is extremely reactive than normal oxygen. Everybody clear? So that is what is the reason. So that is why the nitric acid itself it is reduced into products of nitrites and it will form the water instead of hydrogen gas. So we won't study any kind of reaction, any metal react with a nitric acid other than what? Magnesium and manganese. So these are all the things we studied in our yesterday's class. Am I right, everybody? Clear? All of you? So always please remember, whenever you are studying day by day, if you practice, it will be better easy. That's why class we make attention so that you always make it fair, perfect. And activity we have been proved that which is more reactive, magnesium is more reactive than, aluminum is more reactive than, zinc is more reactive than copper. So this is what it is, the given metal activity series. So activity, the given activity if you have taken. So what is the activity number in our book, everybody? Activity 3 point. Yes, please. Activity 3.11. Am I right, everybody? All of you? I hope everybody done. Please respond. So magnesium greater than aluminum, greater than zinc, greater than iron. So in case of copper, no bubbles were seen. What is the reason, anybody? Everyone? What is the reason
It
copper
is less reactive than hydrogen.
copper is, and even temperature also remains constant. What is the reason? What you notice, everybody? Because copper does not react with what? Copper does not react with the dilute HCl because it is below hydrogen or above hydrogen in periodic table. Sorry, in metal activity series. Everyone speak. It is below hydrogen. So no reaction. We tried or not yesterday book I have shown you or not? All of you. Yes, please respond. Then today's class we are going to study reaction with halogens and reaction with hydrogen. And then only we'll go with the reaction with the solutions. Okay, metal solutions. So the next property is F. So all of you write reaction with halogens. Sir, what do you mean by halogens? So basically periodic classification, 5th chapter chemistry used to get this, but unfortunately periodic classification is deleted. So that's why you learn yourself. Okay, reaction with halogens. All of you listen very carefully. Halogens means in the sense of they are actually first itself I'm saying highly reactive nonmetals. What is that, everybody? Highly reactive non-metals. Understand, Amma? So halogens means which are sea salt producing. So whatever the salt is producing, sea salt, that is what we used to call as halogens. So usually if you take it, we will take halogens means, okay, we will identify it. I will show you in periodic table. So the metals react with the halogens. All of you remember, any metal react with the halogen, but I will show you what are the halogens. Clear, everybody? In periodic table, please respond. So they will metal react with the halogen, they will form ionic halides. What they will form, everybody? They will form ionic halides. Clear, everyone? Please respond. So even these reactions are the best examples for what reactions? Anybody can tell?
Redox.
Redox reactions. Keep it in mind. So The metal here, why means they are best examples. All of remember, metals always get oxidized by how? It will donate the electrons or it will receive the electrons. All of you. Metals will get oxidized by donating electrons. That is what. So the metals get oxidized and halogens. This is H. Halogens, they will get what? Reduced. They will receive the electrons so that they will get reduced or oxidized. Everybody.
Reduced.
They will get reduced. Clear, everybody? All of you? That is why this is the best example of redox reactions. Next, some metals can react directly with halogens. Very important point. With halogens, but some react on heating only. So from this, there is a specification, CBQ question. Anybody can tell? All of you? I will ask you. So the question is, identify a metal whose valency is 2 and reacting with the halogen on heating only. On what, everybody? On heating. Then also you will be having two possibilities, like two metals whose valency is how much I am saying, everybody? Whose valency is 2. Okay. So, but when you write the examples, you identify. Just remember that. So, for example, I'll say, let me take Mr. Wamar. So, they'll ask you in the exam CVQ like, question is, Mr. Wamar identified a metal in the lab whose valency is 2 or even whose valency is not. Who will react with the halogen on only heating, and then down question, identify the metals. Clear, everybody? Next, write the equation, balance the equation. Do you all understand? That is only called as CBQ. CBQ means something, it is not that it is creating and asking. 10th class means 12th class syllabus asking. That is not actually CBQs. Mr. Gogol Krishna, properly name it. I7LS717 is your name. Properly name it, boy. Shall we start now? Halogens means everybody. So anybody, I think already you might be having idea of this elements. So those are very reactive nonmetals. What I said, halogens means more reactive nonmetals. Okay. So very simple. So this is what is our periodic table. All of you observe. Other than hydrogen, remaining lithium, sodium, potassium, rubidium, cesium, and francium. These are called as, anybody can tell? I told you people. What is that called as? Alkali metals. What is to call, everyone? Please learn it. Alkali metals. So lithium, sodium. Next, what else? Potassium, rubidium, cesium, and francium. These are called as what? All of you? Yes, please. Alkali metals. So these are the most reactive metals. Most reactive metals. Because why they are most reactive metals? Alkali metals are highly reactive. So because of one reason, they have a valency electrons. What is the valence electrons of this one? Valence electrons. 1. Valence electrons is 1. And their valence is also how much, Ra? Valence is also 1. So that is why, keep it in mind, who is having valency 1 is more reactive than valency 2 is more reactive than valency 3 is more reactive than valency 4. Do you all understand what I am speaking, everybody? So who is more reactive? The elements whose valency is how much? Whose valency is how much, guys? 1 is more reactive than 2 and 3. Okay. Now, all of you observe these metals: fluorine, chlorine, bromine, iodine. This one, what is that name? Okay, let me verify it. So now you can see astatine is not required. And next one is what is that? Tensacine. Yeah, 10 is 10's a sign. So forget about it. Now you can see that actually you just put a Google in periodic table, you will get very beautifully about all the things. All of you see here how it will be perfectly explained. So this first four alone you learned it. Fluorine, chlorine, bromine, and as well as what everybody? All of you. Iodine. Fluorine, chlorine, bromine, iodine. These four only we used to call. What we used to call everyone? Yes, please. Highly reactive nonmetals whose valency is also, whose valency is 1 and valence electrons are 7. How many valence electrons, everybody? How many valence electrons? Valence electrons are 7 and valence is 1. So to become stable, how many electrons they need? To become stable, how many electrons they need in valence cell? 8 electrons. That is what we used to call as octet rule. Am I right or wrong? You studied 9th class. Correct or not, Ra? Speak, everybody.
Yes.
So that is what. So this one, 17th group. What is the group of this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So 18th group we used to call as noble gases. What is to call, everybody? We used to call as noble gases. So noble gases means unreactive gases. Unreactive gases. Okay, everybody. So before noble gases, so there is 17th group, non-metals. So whose valency is how much, Ra? Speak loudly. Whose valency is how much? 1.
1.
And valence electrons are 7. So these are also highly reactive like alkali metals. Understand, Harish, what I'm saying? So these non-metals also whose valency is 1. So they are also more reactive or less reactive? Everybody. They are also more reactive. Understanding, Amma? See that. Fluorine. Everybody can able to see it or not structure? All of you. How the electrons are rotating. Chlorine. So chlorine means we all people knows. Valency cell. How many electrons is there? Count it, everybody. See that they will take it. How many electrons are there? Count all of you. Valence electrons. 7 electrons will be there. And how many needed for becoming stable? Everybody.
1.
They need 1 electron to become stable. That is what valency is 1. So these non-metals only, fluorine, chlorine, bromine, iodine, we used to call it as what? Everybody? We used to call it as halogens. Okay, ma? So please write it. So who is the halogens? Examples? Usually we will call it as a what? Usually who is the examples of this one? Halogens. Fluorine, chlorine,
Chlorine.
bromine, and
Iodine.
iodine. Okay, so these are halogens whose valence is how much?
1.
1.
Valence electrons. Valence electrons are 7. And what is the valency? Everybody. Valence is 1. So please note it. Any doubt in this? Mithakshari, understand? Mr. Nimesh, Pugal? Yes, please.
Yes, sir.
All of it. Yeah. So please proceed. Make it quick. Any doubt, ask me. Mr. Harvignesh, clear? Arul?
Yes, sir.
Krishna? Yeah. So
Yes, sir.
next, right? Examples will write. So
Yes, sir.
react with that. That's very simple. So here, halogen, first metal, sodium. So sodium react with sodium. What is the physical state, everybody? Solid. Am I right or wrong? You have to speak and you have to do it. Sodium react with a chlorine gas. So what is the product, expected product? Anybody can tell? A very known product. Sodium reacting with the chlorine. We used to get what? Sodium chloride. Am I right? Balance the equation fastly, girls. Girls will balance it. Boys next. Yes, please. Girls, Amma.
2Na plus Cl2 gives 2 NaCl.
NaCl. Boys versus girls. One boy and one girl. Sodium react with the bromine. So bromine is liquid or gas? Anybody can tell? Bromine is liquid.
Gas.
Son, Harizeras, be careful. Reacting, this is liquid. Chlorine is a gas, but bromine is a liquid. Clear? Okay. So what is the expected product? Anybody can tell? Sodium bromide.
Bromide.
Okay. Sodium bromide. Balancing, guys, boys.
2Na, 2NaBr.
Yes. Very good. So 2Na plus Br2 will give you 2NaBr. Every boy take it as a challenge. Girl also. Yes, I should answer. I should answer. That is what. Next. Girls. Magnesium reacting with the chlorine. Yes, everybody. Girls fastly. Magnesium reacting with the chlorine. Product, please. Expected product.
So magnesium chloride.
Magnesium chloride. Directly will come. Magnesium is 2, chlorine is 1. If you crisscross, we'll get Mg1Cl2. So directly. Balancing. Is it balanced or not?
Balance.
Balance.
Balanced. Already balanced equation. That's all over. Next. Boys. Calcium reacting with the bromide. Anybody? Calcium reacting with the bromine. So Br2 again. Liquid. So what will happen? Anybody?
CaBr2.
CaBr2. So what is the name of it? Calcium?
Calcium bromide.
Yeah,
Bromide.
calcium bromide. Small bira. Calcium bromide. Balancing equation. Is it balanced or not?
Sir, balanced, sir.
Yeah, balanced. Ca and Br. So Ca valence is 2, Br valence is 1. So if you make it, what will happen? CaBr2. See, like LKG, even third chapter, I am teaching the chemical formulas. So you should understand what is the importance of chemical formulas. If you don't know chemical formulas, there is not necessary to read at all. So please understand, there is no use of studying chemistry without knowing the chemical formulas. So stress on it. Omar, I want to hear your voice. Next question. So that's what. So please speak. Next, zinc metal. Zinc reacting with the chlorine gas. Yes, Omar, can you tell me what is that? Answer, please. Omar. Answer, boys. Sanjay. Zinc. Respond, Ra. Zinc chloride. Okay, everybody. So for this only we need heating. Zinc won't react with the halogens directly. They need what, everybody? They need
Heating.
what? Heating. So please remember that. Now you understand what is the metal identified by Mr. Omar in the lab? What is the metals? Either it is zinc or it is, what is that metal?
Copper.
Copper. So CuCl2. So that is what you have to remember. Both need heating. So this is the metals possibilities for you. Next, iron. So iron, anybody can tell, girls and boys, everybody. So iron will react with the chlorine. What is the products? Anybody? No heating is required. Now this is called as
FeCl2.
copper 2 chloride. Copper 2 chloride. Okay. Yes. Next. Iron is react. F, please speak everybody. Fe.
Cl3.
FeCl3. This is ferric chloride. Iron always what we are expecting formula is different. Be very careful. Balance it fastly. This last equation is not balanced. Balance it. Mr. Omar, I am removing you from meeting. Hello.
2Fe plus
Balance
3Cl2 gives
fastly. Girls, what is this much time? 2Fe plus
3Cl3.
3Cl2 gives you
2Fe.
That's all it is. Okay. So this is what? That is why these questions are, these examples are best examples for what? Redox reactions. Because metals will get oxidized by donating electrons. Halogens, they will get reduced by receiving the electrons. That is what you have to remember. Okay, guys, all of you. Harizeras, understand? Vijay. Okay. So please proceed. Anything doubt, anybody can ask me. Next. Completed, everybody. Reaction with halogens. So halogens means, I hope you all understand. What is the examples of halogens? Fluorine, chlorine, bromine, and iodine. Okay, guys. Next one. Reaction with the hydrogen. Reaction with what? Everybody?
Hydrogen.
Hydrogen. Next, property number G. Reaction with the hydrogen. So remember, here, the most important thing. So as we know that hydrogen is a non-metal, but still it is placed in the activity series. Am I right or wrong, everybody? Even though it is a non-metal, it has been placed in the activity series. Is it true or not, everybody? Yes, please. Because what is the reason? Most of the cases, even though it is a non-metal, it will behave like a what, guys? Respond, Ra. It will behave like a metal, and it will lose the electrons or will gain the electrons. Everyone, it will lose the electrons many times. Okay, so that is why even hydrogen is a non-metal. What is the reason it has been placed in the metal activity series? So let me wait. Let all of you wait. I will teach you that first and then only wait. So basically in metal activity series, hydrogen is placed or not, everyone? At least that you speak. Am I right or wrong? Metal activity series, hydrogen is placed or not? All of you. Innara?
Yes, sir.
Yes.
Why it is placed? Anybody can tell. What is the reason why hydrogen is placed in the metal activity series? I want to know. Speak. What you are expecting answer?
Like metals in many cases.
Even though it is a non-metal, it will many cases it will donate the electrons instead of receiving the electron and try to become stable in nature. So this is 8th class book. What is the special features of activity series? Pakranga. Everywhere. Have you checked it? Hydrogen is present or not in metal activity series? See that. Please never call me a zebra. I like hydrogen. Call me a pretty girl. Pretty girl. Am I right or wrong? We studied or not? All of you. Yes?
Yes, sir.
Yeah. Now, why hydrogen is included in metal activity series? Teriada, you should ask me, or else you should learn. What is the reason? Everybody, read the second point. Why hydrogen is included in metal activity series? What is the reason, all of you? Hydrogen is included in the metal activity series because, like metals, it will lose the electrons or gain the electrons. Everybody, it will lose the
Loss.
electrons in many cases, and it will turns into positively charged H plus in most of the chemical reactions. That is the reason hydrogen, even though it is a non-metal, it is considered like a what? Everybody, it will consider like a metal. So most of the chemical reactions, it will lose the electron. Already it has only one electron. That electron also, it will lose that electron, and then it will become stable in nature. It will turns into H plus. That is the reason it is considered as a metal and it will be placed in the metal activity series. Do you understand, guys, what I'm speaking? Girls, understand? All of you?
Yes, sir.
The reason. That point you learn, I'll send it. Everyone, you have to learn. Okay, everyone? So since metals as well as hydrogen, since metals will form the compound by loss of electron or gain of electron. Everybody.
Loss of
Loss of electron. So same like metals, hydrogen also. Hydrogen form compounds by loss of electrons or by gain of electrons. Everybody. By losing electrons. So that is why you can notice it. Hydrogen is also included in the metal activity series. But if you see, metals usually do not react with the what? Usually do not react with the hydrogen. Why? Many metals are placed above hydrogen or below hydrogen in activity series. Above hydrogen or below hydrogen? Above hydrogen. But very few, only few alkali metals. That is also very few alkali metals and other reactive metals. Reactive metals react, okay, with hydrogen and they will form again ionic hydrides. What it will form, everybody? It will form ionic hydrides. Clear, everyone? See, metals reacting with the halogen, they will form a compound name called as, I have written here. What is that? Ionic halogen. Halides. Understanding? Ionic halides we say. Here they will form ionic hydrides they will form. So in these hydrides, in these ionic hydrides, metal behaves as halogen. Understanding? Very important. Please remember that. So basically, hydrogen also will lose the electron, but in these cases, in this particularly halides cases, clear everyone? So in these hydrides cases, hydrogen will lose the electron or it will gain the electron. Everybody, already metals are dominating than this. Then what will happen? Hydrogen behaves as, basically it will donate the electron, but in these situations it will behaves like a halogens and it will form, receive the electrons. So to receive the electrons, what will form? Anion or cation? Receive electrons. Anions. Okay, in these cases. So that is why these are highly reactive and explosive compounds. They can give hydrogen on reaction with even water or by absorbing moisture from the atmosphere. So extremely dangerous one. These are very, very reactive and explosive compounds. So for example, sodium. So as I said, sodium is alkali metal or not? Everybody, will you agree with me? Sodium is alkali metal or not? It will react with the hydrogen gas. So in this case, hydrogen is acting like a metal or acting like a halogen? Acting like a what? Halogen, and it will form a compound called as sodium hydroxide. Sorry, sodium hydride. Write it. Sodium hydride. Balance it fastly, girls. Yes, please. 2Na plus H2 gives you 2NaH. That is what it is. So make it. So very few alkali metals only react. Now, these sodium hydroxide will react with the water. Just now I said either from atmosphere or from directly reacting with water. It will turns into what? Explosive, highly reactive and explosive. So that is what it is. If these products, hydrides, sorry, what is that? Hydrides reacting with the water, it is extremely exothermic reaction, highly reactive, okay, and explosive. With what, guys? All of you? Explosive with what? With the water or by absorbing moisture. Absorbing moisture. Be very careful. So what is the product expected here? Anybody can tell? NaH reacting with water. Speak loudly. We all know that product. Sodium hydroxide. Plus it will give us what? That's what I'm saying. It will give us back what? All of you. Hydrogen. Understanding, Amma?
Yes.
So that is what. So what is the balanced equation? Boys can balance it fastly. Balance this equation fast. Anybody can balance. Inga 3 hydrogen irukka, inga 2 hydrogen mattum da irukka. So I'll make it here even number 2H2.
Already balanced.
No, how it is balanced? Hydrogens are not balanced. Pakranga.
Sir, here NaH,
Balance, sir.
already balanced.
Yeah, but we got it here NaOH illa Harish. Here what we got it? You understand, Harish?
Where, sir?
Up reaction what we are getting?
NaH, sir.
Yeah, this product is the reactant for the second equation. Understanding, huh?
Yes, sir. So 3 hydrogens, right, sir?
Yeah, 3 hydrogens are 2 hydrogens are verified.
Sir, H2O, sir. H2 and here H3 hydrogens.
No hurry. Actually, the first reaction is sodium reacting with the hydrogen. It will form sodium hydride. And what is the statement we are making? These hydrides will react with the water. It is highly explosive, highly reactive and explosive. And they will give backs. They will give back what? They will give back hydrogen. That is what is our statement. Do you understand?
Yes, sir.
Yeah. Then what is the product here? We got it. Sodium hydride, 2NaH. So 2NaH react with the water. It will give you NaOH plus hydrogen. Now you balance it. Is it correct or not? Verified?
So you have to take the 2 NaOH, sir.
Yes, Harish. Because this is the product in the first reaction. That is what I'm saying. What I'm saying. The hydride is reacting with the water. It is highly reactive and explosive. Clear, everybody? Ms. Harish Zairaz. Do you understand? Mitakshri? That one is highly reactive and
Yes, sir.
explosive, and it will gives back what? It will gives back hydrogen. That is the equation. Understand, Hari?
Yes, sir.
Okay, that is what. Okay, next, calcium. Very few metals will react. Calcium reacting with the hydrogen. So what is the expected product? Anybody can tell? Meeting is going to end. Join very quickly. Pause. Calcium is reacting with the hydrogen. Product, please. Calcium hydroxide. Sorry, calcium hydride.